Now, how do we start with the first one? You have any idea? Any idea?
No, sir.
Okay, no problem. So usually the first type of factorization that we did was about taking out the common factor, right?
Yes, sir.
So if you see these type of problems, these are the problems that involves factorization by grouping. How do you pick up that these types are factorization by grouping? You check the structure. Usually they will try to hide it, but you can see the structure. For instance, a 3:1 structure. Here also it's 3:1 structure. So how do we group the two? So number E, 3x to the power of 3 plus, let's see, plus x squared minus 3x minus 1. If you group these two and you group these two, eventually you will have a common factor. And that common factor will be an expression. So between these two, do we have a common factor? Miss, do we have a common factor?
No, sir.
Between these two, is x not a common factor? Or let me say x squared.
Yes, sir, it is.
So if we take out x squared, what are we going to be left with between these two?
Three, sir.
3x and plus 1. Okay. Now we have minus 3x minus 1. The trick is, are we able to factor out something in such a way that we are left with 3x plus 1 when it comes to this expression? Do you think we can do it? And which factor can we take out so that we can be left with 3x plus 1 somewhere, somehow on this expression? Because that's what they are trying to do. If you take out minus 1, you'll be left with what?
3x, sir.
3x plus 1.
Yes.
You agree?
Yes, sir.
So do we have a common factor?
Yes, sir.
Which is
1.
No, this is common. Do you see the common factor? The common factor is 3x plus 1. If you take out 3x plus 1, you will be left with x squared minus, here you will be left with minus 1. So are we done factorizing? Are we done factorizing?
Yes, I think so, sir.
How about this expression? Is it not the difference between two squares? This is the difference between two squares. Which is going to be plus and minus. You agree?
Yes, sir.
Yeah. So you get all your full marks if you end it right there. Okay. Number F. We have m squared m to the power of 3 minus m squared minus mn squared plus n squared. Usually, if you see four terms, usually what they're trying to do is for you to factorize by grouping. Usually, if you see four terms or if you see a lot of terms, usually they want you to group. So, which group do you want me to do first?
Your choice, sir.
Which one?
You can go with your choice.
No. I want you to make a choice. Okay. Let's try to group these two. Okay. Do we have a common factor between these two?
Yes, sir. Same.
It is m squared into m minus 1. You agree?
Yes, sir.
Then minus, here, do we have a common factor?
Yes, sir.
It is
N, sir.
n squared. Then what are we going to be left with if we take out the minus n squared?
M plus 1.
It can't be plus. It should be a minus because I took out minus n squared. Negative by negative will give us positive. So if I take out minus n squared, I will be left with a minus. But if this was a plus, I would agree with you.
Yes, sir.
Okay, let me do it your way. So do you agree that if I take out n squared, I will be left with a minus m here? You agree?
Yes, sir.
Then plus, I'm gonna do it your way. Plus, not plus n, man, plus 1, like you said. I see what you were trying to say. Plus 1. That's okay. We have m squared, m minus 1. But then here we have a minus m plus 1. How can we make it to look like that? We have to take out a common factor, which is a minus 1. You agree?
Yes, sir.
Then that minus 1, I will multiply it with n squared, and it will give me a minus n squared. Then if I take out a minus, on a minus m, I will be left with m. If I take out a minus on a plus 1, I will be left with a minus 1. Okay, now we're here. Do we have a common factor?
Yes, sir.
which is
M.
it is
M, sir.
M. No, it can be M because you will only find M this side. You don't have M this side. The factors that we are talking about, factors can be written in a form of A times B. These are factors. In M squared times M minus 1. These are two factors. You agree? And
Yes,
these
sir.
two factors are separated by a minus. And on the other side of a minus, you have two factors, n squared times m minus 1. These are two factors. This is a factor and that's a factor. This is a factor and that's a factor. So on the either side of the minus sign, is there a factor which is common? Is there
Yes,
a factor which is found on
one.
both sides?
Yes, sir.
Which is
M minus 1.
perfect. Then what are we left with on this side? If we take out m minus 1, we'll be left with m squared. You agree? You agree?
Yes, sir.
M squared. Then on the other side, I'll be left with minus n squared.
N squared, sir.
Perfect. Do we have any further factorization that we need to do? Because you must always be on the lookout for further factorizations. Do we have it? Do you see anything that has to be further factorized, Kumis?
No, sir.
Okay. You remember the list that I did for you about the types of factorization? You must always be on the look for the difference between two squares. Do you see that this is a square and that's a square? So this is a difference between two squares. You can't leave it like that. It is not fully factorized. It is the same thing that I did here. So you must always be on the look for the difference between two squares. You agree?
Yes, sir.
Okay, so we're gonna have m minus 1 into how do we factorize this difference between two squares?
Yes, square roots.
Yeah, square root of m, it's m. I agree with you. Then the square root of n, ne?
Yes, sir.
It is
N.
Perfect. Two square roots. I'm just gonna write the same thing. Okay, now how do I place the signs? Kumis?
Plus and minus, sir.
Plus and minus. Perfect. Now it is fully factorized. Okay, number G. Let me copy it the way it is. So it is y plus 3 2y minus 3. Y plus 3 2y minus 3. plus y the minus, yeah, y minus 1, then p minus 2y. So with the difference between two squares, what they are trying to do is they want you to be able to spot out a factor that you can take out. So in this case, are you able to see something that when we restructure, we can take out a common factor on either sides? Do you see something, Kumis? Do you see something that if we restructure, we can find something common? Already, here we can pick up something common if we restructure. Okay, plus 3. So if I take out a common factor here, or if I try to restructure and take out a minus 1 as a common factor, I will get minus 2y minus 3 plus 3 plus y minus 1, 3 minus 2y. Do you agree that somewhere, somehow, this expression and this one are the same?
Yes, sir.
Yeah, but I'm just going to write it properly. Minus 1 times, this will be 3 minus 2y plus y minus 1, 3 minus 2y. Okay. Let me take out this minus and put it here. So we're going to have minus 3 minus y plus 3. That's fine. Okay. Do you see a common factor?
Yes, sir.
What is our common factor?
3 minus 2y.
Okay, 3 minus 2y. Then what are we left with this side?
Y plus 3. It's negative.
Yeah, that was the
y.
next. Okay, we are left with negative y plus 3. That's perfect. Okay, and this side, on the other side of the plus sign, what are we left with?
Y minus 1.
Perfect. Okay. This will be 3 minus 2y. And then if we take out the brackets, we're gonna have minus times y. It will give me a minus y. You agree?
Yes, sir.
Then again minus times minus 1 times 3. It will give me
Negative 3.
yes. Then plus, okay, 1 times y, it will give me a y. Ne? Then 1 times minus 1, it will give me a minus 1. Okay. Do you see that if we add these two like terms, it will give us a 0?
Yes, sir.
Okay. So we will have, okay, these two will eliminate each other. -3 -1, it will give us a -4. So we will have 3 minus 2y times a -4. So this is equals to -4 into 3 minus 2y. And you get your marks. You've done factorization. This is a factor and that's a factor. Perfect. Okay. The last one, number H. H will have x squared 2x plus 1. X squared 2x plus 1 into the minus 2x into 2x, I think 2x minus 1. No, the first one is a -1. It's not a +1, sorry. -1. Then minus 3 into 2x minus 1. Okay? So, Mr. Do you see a common factor?
Yes, sir. It's 2x minus 1.
2x minus 1. Then what are we left with?
X squared.
Minus 2x minus
3.
3. I'm very interested in this one. This is going to tickle your mind. Okay, so we have these two factors. They can be expressed in a form A times B. Okay, are we done factorizing? Are we done factorizing? Yes,
Yes, I think so.
these people will always trick you. Remember on the second step, they know very well that normally after factorizing on the first step, the second step will have a further factorization. Do you pick up any further factorization needed? Remember, the first type of factorization was taking out the common factor, and the second one was the difference between two squares. You remember?
Yes, sir.
And the third one was factorizing a binomial, a trinomial, sorry. Yes, factorizing a trinomial. And the third one was factorizing by grouping, which is what we are doing. And there's also those two, a difference between two cubes and the sum of two cubes. So it's not much, really. So let me list all of them again. Number one, common factor. Number two, difference between two squares. We're talking about a squared minus b squared form. Number three, we have a trinomial. ax squared plus bx plus c. Number 3, we have difference plus the sum between two cubes, which is a to the power of 3 plus b to the power of 3, and a to the power of 3 minus a to the power b to the power of 3. Yeah, that's about it. So do you pick up any type of factorization from the one I've listed? Are we supposed to take out the common factor? Do we have the common factor? No. Do we have the difference between two squares? I don't think so. Do we have the trinomial?
Yes, sir.
Okay, so how do we factorize the trinomial? 2x minus 1. Okay, so that's your expression. That's your trinomial expression. Your trinomial expression. Okay, so you have x squared minus 2x minus 3. So now how do we factorize this trinomial? Using the notes I have given you last time. How do we go about it? Where do we start? You're gonna have to list the factors of the two extreme. You have 1 and minus 3. What are the factors of 1? 1 times 1.
1.
And 1 minus 1 times minus 1. That's okay, right?
Yes.
And then for minus 3, you have
1 times
minus.
3.
Okay, yeah, you're right.
It's negative 1 times 3.
Or you're gonna start. Okay, let's start with minus 1 times 3, and we also have 1 times minus 3. You agree?
Yes, sir.
Okay, let's do our combinations. Okay, let's do our combination. The first combination is gonna be what and 1?
1 and
Plus 3 times 1, which is going to give us minus 1 plus 3. It's going to give us a plus 2. The second combination will be, again, I'm going to take the same product and multiply it with the second expression. So we're going to have 1 times 1 plus 1 times minus 3, which is going to give us, Kumis, are you still there? It's going to give us a minus 2. Perfect. I think without us even going further, we already have a number which is the same as the middle term. So we're done, basically. So to put these as factors, we will have x we will have we are going to have 1 times 1 times 1. This is what we have first, and we will have 1 times, no, this is not it. It is going to be yes, 1 times 1 and 1 times 3. 1 times minus 3, sorry. 1 times minus 3. These are the two pairs. 1 times 1 and 1 times minus 3. However, this is 1x. So this will be your x, and this will be your x. And your 1 is a plus 1. So these are your factors. Do we have any further factorization needed?
No, sir.
Okay, that's perfect. That's perfect. So that's about it. So I just want to see if there's any example. Yeah, I just want to move on to this type of problems. Okay. So I just want to make a quick screenshot. Okay. Insert blank page. Okay, so can you, as I'm busy doing what I'm doing, can you name all the types of factorization that you know? The first one, okay, taking out the common factor,
Difference.
the difference between,
of two squares.
yes, any other,
Factorizing trinomial.
okay, and then the next ones,
Difference cubes.
yes, and lastly, okay, number 8, we are going to simplify, and as we simplify, you need to have all the types of factorizations in mind. Now we are going to apply everything. This is going to test your mind. Okay, simplify. The first one, we have x squared minus x minus 6 over x squared minus 4x plus 3. Okay, do you see any form of factorization you can apply? Who miss? On the numerator, do you see any?
Factorizing trinomials.
Okay, that's perfect. And then how do you factorize the top one?
Also factorizing trinomials.
You agree that this is how we do it. Okay, you agree? Any
Yes,
other
sir.
factors? Any other factors?
For both the numerator and denominator.
No. I'm only focusing on this one because we have to factorize one at a time. You can't mix the two. Just act as though the denominator is not there. I just want to factorize the numerator first. I want factors of -6. Possible factors.
It's negative 6 times 1.
Okay. -6 and 1, yes, we have already done that. Do you agree with that one?
Yes, sir.
Any other? Any other?
No, sir. No, sir. Oh,
Oliver? No.
3 times -2, then it's 2 times -3.
Yeah. Perfect. Okay. Let's do our combinations. Okay. The first one, number 1, we're going to have 1 times 1 plus 1 times -6, which is 1 minus 6. Going to be a -5. The second combination, 1 times will be 1 times -1 by 1 times plus 1 times 6. This will give us plus, it will give us a 5. Third combination, it will be 1 times -3 plus 1 times 2. What do we get? A minus?
-1.
-1. Are we sorted yet, you think?
Yes, sir.
Okay, perfect. So we have factors now, right? For the top one.
Yes, sir.
So how do we factorize it? So you agree that it will be a 1 times -3. You agree?
Yes, sir.
And then the second one will be a 1 times 2. And these two are x and x, right? So this was the plus. These are the two factors. X plus 2, x minus 3. divided by the bottom one. What numbers? So what are we going to do now? Which extreme factors should we consider? To me,
1 and 3, sir.
1 and 3. 1 and 3. So 1 will be 1 times 1. And minus 1 times 1, minus 1. That's also possible. Then with 3, we're going to have 1 times 3 and minus. We're going to have 1 times 3 and minus 3 times
minus 1.
Minus 1. Perfect. Okay. Do you have any other? I doubt. Make sure that all the factors are listed. It's fine. First combination, we're going to have what times what? Miss.
1 times 1 plus 1 times 3.
Which is 4.
4, yes, sir.
Number 2, we will have
minus 1.
No, remember you have to go back to the
1
same.
times.
Remember you have to go back to the same combination you were doing. You must do on both. You must start with that one and then do that one. Then when you're done, then that you will come to this one and attack the 2. 1 and then 2. That's how you do it. Okay, so what do we have? Use this one and this one.
Times 1 plus minus 3 times
1 times minus 3 plus 1 times minus 1. So what do we get? What do we get? Minus 4.
negative 4.
Yeah, minus 4. Are we sorted yet?
Yes, sir.
Okay, perfect. So factors, we're going to have, you said 1 times, it's going to be 1 times
minus 3.
minus 3. And then here we're going to have 1 times 1 times minus 1. You
1.
agree?
Yes, sir.
And these are 1x and 1x. So this is x and that's x. So we have factorized there. So we're going to have x minus 1 into x minus 3. So this is what we have so far. So what rings a bell? Are we done yet? To miss.
No, sir.
So what can we do now?
Taking out the common factor.
Which is?
X minus 3.
If I take it, I'm just going to take x minus 3 and bring it here. And that's really not taking out the common factor. Why don't you cancel the 2 factors? Have you guys done this thing of canceling the denominator and the numerator? You know when to cancel? Kumisa, do you agree that I can actually cancel the two? Kumisa, are you still there? Are you still there? Kumisa, Kumisa, are you still there? Because I can't hear you properly now. Okay. Wow. Reduction formula. Okay. Okay. Reduction formulas. Okay. Derive reduction formulas. Okay.